Myself, Dr. Deepak Kumar Paswan, Assistant Professor in Mechanical Engineering Department of Tulsiramji Gaikwad Patil College of Engineering and Technology, Nagpur. I am hereby going to deliver a lecture on the topic of Introduction to Kinematics of Machines. Here we start with the introduction, which includes introduction, that is definition of links, element, kinematic pairs, degrees of freedom, kinematic chain, mechanism structure, inversion machines. And the second one is the kinematic chains and inversions. Includes inversion of 4-bar chain, single-sided chain, double-sided chain. Now we start with the basics, that is terminologies of machine. So by hearing the word machine, which implies that in our day-to-day life, we go through the machine process in our daily life. That is, machine is basically a device that transfers the motion and force, that is power, by getting from the input to the load, that is output, which basically transform the energy of another form into the useful work. Okay. So in our daily life, machine is a device that receives energy in some available form and it utilizes to do some work. Here we understand this by this example. This is a single slider crank mechanism having cylinder and piston system which have the reciprocating motion, which is to and fro motion, which will transfer to the crosshead, which is connected to the connecting rod, which further connected to the crank. Okay. So here the piston moves in a cylinder piston arrangement. With here is a gas or fluid there through which the pressure increases, the pressure, the volume decreases, and volume decreases means high pressure generated. So the piston moves there forward so that this motion called reciprocating motion, having to and fro motion continuously, transferred to the small bearing in a connected with a crosshead, which further connected to the connecting rod, and through this the reciprocating motion is converted into the rotatory motion, which is further connected to the crank and attached with the flywheel, and the flywheel has a purpose to restore the energy and reduces the vibration during the circular motion, rotatory motion of the crank. So, in this single slider mechanism, the sporting motion is converted into the rotatory motion. So, here is the classification of motion, that is, it is classified into continuous rotation motion, that is, a body moving a circular path about a center, which gives the continuous rotation motion, and second one is the linear motion, that is, which continuously moves in a linear path, that is also called the rectilinear motion or translatory motion. Another one is the intermittent motion. Intermittent motion, it continuously moves without losing its motion, that it is used in the Geneva mechanism. Another one is the angular oscillation, which oscillate, that is motion in an angular oscillation. It is called angular oscillation. Here some basic definitions used in a machine, that is element or link. Another one is the kinematic pair, kinematic chain, and the mechanism, machine and structure, degrees of freedom, Grobler's criterion and inversion. Another one part is the kinematic chain and inversion. So kinematic chain and inversion are of three types: inversion of 4-bar chain, single-sided chain mechanism, and double-sided chain mechanism. Here are the basic definition. First, we go through the link, element, then kinematic pair, joint, kinematic chain, mechanism, and machine. We will discuss in the next part. So here we start with the kinematic link or element. So each part of a machine is made up of the component, single component. That single component is known as the link or element, which moves in a relative motion with each other to transfer the one form of motion to do some useful work. This component, each component is simply called as kinematic link or simply link. And here is this is a setup called single-sided mechanism, which is connected having a system of piston and cylinder arrangement with carrying gases or fluid through which the high pressure is created and temperature is created so that the volume decreases and create the to and fro motion, which is further transferred into the crosshead having a small end bearing which transfer the motion crosshead to the connecting rod, which converts the reciprocating motion into the rotatory motion, which further connected to the crank and attached with the flywheel. Flywheel, the purpose is to restore the energy and reduces the vibration and provide the uniform motion to the crank. So in this setup, the action or reciprocating motion converted to the rotary motion in a single-sided mechanism. And these are the different types of link. First is the rigid link, second is the flexible link, third is the fluid link. And the rigid link, first we start with the rigid link. So rigid link comes with the rigid. Rigid means a body which cannot deform by applying external force on it. So this type of link which cannot be deformed during motion, its shape and size cannot be changed, but the rigid body cannot be practically obtained because it is ideal condition. So the body near about in the rigid condition, that is called rigid body, which does not undergo any deformation while transmitting the motion. So this type of link is called rigid link. Another one is the flexible link. Flexible means we can see the belt, ropes, chain. So these are the devices which transfer the motion without changing affecting the transmitting motion. So it partly deforms, its shape is partly changed, but totally cannot affect the transmission of the motion. So this type of link is called flexible link. Example: belt, ropes, chain and wires. Another is the fluid link. Fluid link we can see that the very hydraulic machines having the hydraulic mechanism which transmit the motion by the use of fluid pressure. So link formed by having any fluid. So any link that is formed by the having fluid which transmit the motion through the fluid pressure. So fluid link is what? It is a link which transfer the motion by the fluid pressure. Example: hydraulic presses, jacks and brakes. Now, links can be classified into unary link, binary link, ternary link and quaternary link. So unary link is having one node. The link having one node point is called unary link. Another is the binary link. The link having two joints connected with the one another link so that it has two nodes. It is called binary link. Similarly, the link which is connected to other link at 3 points. Here you can see the figure diagram 3 points. So it denotes the ternary link and the binary link having 2 points. Similarly, quaternary link that is connected to the other links at 4 points. Means 4 links are connected in a 4 point. So this is called quaternary link. Now structure. Structure is basically different from the machine, because in machine all the members component are in relative motion with each other, but in a structure there will be no relative motion between the members or component which carry load or having straining action. Okay, so in a structure is an assembly of resistance body having no relative motion with each other. Example, railway bridge, roof stress and a machine frame. Here are the difference between the machine and structure. So the part of machine that moves relative to one another, whereas the members of structure does not have any relative motion with each other. So these are the major differences between the machine and structure. And another point is that machine transfers the available energy into some useful work, whereas in structure no energy is transferred into the useful work. And the link of a member may transmit both power and motion, but the structure member does not carry any force; it carries only bearing member. Now, structure only carries the load; it does not have the relative motion with each other. So these are the differences between the machine and structure. Now we come to the kinematic pair. When two links or elements, components of a machine join with each other in a contact so that it form a pair which having the relative motion between them which completely successfully constrained, means having definite direction. Two elements or link join with each other so that having a definite direction motion, it is called completely or successfully constrained motion. This here a square hole and a square bar having definite motion, so it is a completely or successfully constrained motion. Similarly, the load or shaft in a footstep bearing is the example of completely or successfully constrained motion. And these are the constrained motion. When two elements are limited to move or motion in a respective direction of the force applied, means their motion will be irrespective on the force applied. So this type of motion is called completely constrained motion. Example, the motion of a square bar in a square hole. This is the example of completely constrained motion. And another one is the incompletely constrained motion, when the motion between a pair takes place in more than one direction. Means motion will be more than one direction, not different direction. It has more than one or more direction. These are called incompletely constrained motion. Example, a circular bar or shaft in a circular hole. Okay, a circular bar or in a circular hole, it may rotate or slide. Means it has two type of motion: rotate or slide in a hole. So these motions have no relationship with each other. That is automatic. So a circular bar or shaft in a circular hole may have rotate or it may slide. So it has two different directions of motion, more than one direction motion. Another is a successfully constrained motion. When the motion between the elements may when the two links are combined with each other to make a pair which are having relative motion with each other in such a way that the constrained motion cannot be completely by itself but by some another means. We have to forcefully constrain it by some another means. Example, a shaft in a four-step bearing or IC linear valve. We are making a valve to forcefully constrain it and piston inside a cylinder. So these are the example of successfully constrained motion. Now the classification of kinetic pairs. according to the relative motion of the elements, it can be first type will be sliding pair, that is prismatic pair. When the two elements of a pair are connected in such a way, it can only slide it to the each other, has completely constrained motion. Example, the piston and cylinder arrangement, cross head guides of a reciprocating steam engine, and the ram and its guides in a safer tail. And another one is the turning pair. When two or more pairs of elements are connected in such a way, they can turn with each other. So this type of pair is called turning pair. Example, the lathe of a spindle supported in a headstock, cycle wheels turning on their axle. So these are the example of turning pair. When two connected pair connected with each other, that the motion are turning. So these are called turning pair. Another one is the spherical pair. So in such a way, when two or more elements are connected with each other, so that it will turn or swing about a fixed point. Example, a ball and socket joint is the example of spherical pair. Similar to the attachment of car mirror, we can move in the all the direction, and the pen stand, so it has a spherical pair, so that two or more elements connected with each other, which can swing or turn about a fixed element, is called spherical pair. Now the screw pair. Screw pair is such that it can connected in such a way that one element can turn another by a screw thread. It is correct. It make pair with a screw thread, having screw thread, so that it can turn about that the screw thread. Example, lead screw of a lathe without nut, and bolt and nut bolt is the best example of screw pair. Another one is the cylindrical pair. If the motion between the pair elements combine in such a way that the turning and sliding, means cylindrical pair have both motion, turning and sliding motion. So the combination of turning and sliding motion of a pair is called cylindrical pair. This is the collar, hole and shaft, circular shaft. This pair is called cylindrical pair. Another one is the rolling pair. When two or more elements make a pair in such a way that they can roll over a fixed length. For example, ball and roller bearings. This is the ball and roller bearings. So the balls are rolling over this bearing based on the railway wheel. Railway wheel, the track is fixed and the wheel is rolling over the track. So it is the example of rolling pair. Another one is the classification of kinetic pair in the nature of contact between the elements of link. First is the lower pair. Lower pair means the two pair of link which having motion in such a way that they have the surface contact, or the surface contact in such a way that the one element will slide over the another surface of the link. Example, sliding pair, turning pair, screw pair and lower pair. They have the surface contact, so it is called lower pair. Another one is the higher pair. Higher pair, when two elements have line or point contact. When two legs or elements of a pair having the line of contact, or point of contact, and the motion between the element is partially turning or sliding, it is called higher pair. Example, tooth gearing, belt and rope drives, ball and roller bearings, and cam and follower, which are having point of contact or line of contact with each other. So it is an example of higher pair. Thank you.